One of RxJava's greatest strengths and most commonly used feature can turn into a detriment if it isn't used properly. I'm referring to its ability to seamlessly switch a workload between multiple threads by using the subscribe-on and observe-on functions. At its core, you must understand how RxJava flows work and what the role each of these functions play. Without a correct understanding of this, it's easy to add unnecessary work to your app, and even have your app crash and blow up in your face. Metaphorically, of course. Today, I'll show you how these flows work and how to properly leverage the subscribe-on and observe-on functions to achieve what you need without creating elusive bugs. Before diving into RxJava flows, let's discuss schedulers. RxJava has pre-created thread pools that it calls schedulers. In most cases, these behave much the same as normal threads, so that means schedulers are susceptible to the same bugs that you'll find with the improper use of threads. Threading bugs can be hard to detect, and even harder to fix, so we want to avoid these altogether. If you don't understand how RxJava passes a job between these different schedulers, you can end up putting some work on the wrong thread. In some cases, you might just see performance issues with like a stuttering UI, for example. Other cases, you might end up seeing some unexpected exceptions, which are really hard to find and recreate. Plus, context switching a job between different threads isn't cheap, so you want to understand when you want to do these switches, and then do them judiciously. As we know, code executes from top to bottom, and the same goes with RxJava, but the subscription flow goes in the opposite direction, from bottom to top. Now, why is this? I typically like to use a metaphor to explain this. Nothing in an RxJava stream happens until you call the subscribe function. It's sort of like a relay race where you have everybody at the starting line until you fire the metaphorical gun to start the race. The gun, in this case, is going to be the subscribe function. So in turn, each of these steps take a lap around the track, performing some kind of operation before handing the baton to the next person to perform the next lap. And that is the lifecycle of an RxJava call chain. Subscriptions is really just a term that we use to describe a particular function that's waiting its turn to run a circuit around the track. So if I drop the metaphor and return to code, each function waits for a response from the previous function further upstream. So listening for an upstream response and subscribing is really describing the exact same idea. So for this example, this map function is subscribing to what's emitted from the previous function. And this map function is doing the same to what it was given, and on up to the top. Now let's switch gears to the observer flow. Now, observer flows work just like any regular code, so that means from top to bottom. And the simplest explanation I can give is that observers are really just any function downstream from you. They observe what was given to them from a previous step whenever their turn arrives. So in this case, this map function observes what was given to it from a previous function, and this map function does the same thing, all the way down to the subscribe function. So you could say that the subscribe function is the final observer of every RxJava flow because it always receives the end result. The top function, on the other hand, doesn't subscribe to anything, and the bottom function doesn't have anything observing it. Let's take a look at a few examples that properly use this context switching in practice. Before moving on, let's take a minute to explore other learning opportunities that you can get for free. If you're looking to build modern apps for Android tablets and foldable phones, you can get my course on Skillshare. You'll learn how to use cutting-edge tools to build responsive apps for the latest types of devices that are hitting the market. You can use this link to get my course and thousands of others for free for 1 month. Click the link now to sign up and start watching the course Foldable and Responsive Android Apps with Jetpack Compose. Now, let's get back to the content. The observe-on function is really quite straightforward. It's sort of like going to the gym and lifting 3-pound weights. Easy, right? So let's start with this easy example. I'm going to use the debugger to see what's going on with each of these steps. So I'll place a breakpoint at the first flat map, and the second, and then the subscribe. So as I mentioned earlier, observe operations go down. So I would expect the first flat map to be on the default thread, and the second one to be on the IO scheduler. But what about the subscribe? Let's try it out. My first breakpoint shows that I'm on the default thread. In this case, it simply calls it main. You can think of that as being the UI thread. If you're using Rx Android, this will be equivalent to the main thread scheduler. The next function you can see is running on the Rx Cache thread scheduler. This is what RxJava calls the IO scheduler behind the scenes. So I definitely did a context switch between the main thread and the IO thread scheduler. Observe-on changes the thread that we use for everything downstream, including the callbacks and the subscribe function. Let's change this code. I'll add one more flat map right at the very end before my subscribe. Before it, I'll observe on the computation scheduler. I'll put a breakpoint inside of my new function, And then I'll debug this application one more time. When I hit my first breakpoint, I'm obviously on the main thread. And if I continue on to the next one, now I'm on the IO thread. The next breakpoint puts me on the computation thread, or as RxJava calls it, the Rx computation thread pool. And one last time, whenever I land a subscribe, I'm still on the computation thread scheduler. So as you can see, the moral of this story is it uses the thread scheduler of your choosing until told otherwise. And they lived happily ever after. The end. Subscribe on behaves a little bit differently. This is sort of like going to the gym and lifting 10-pound weights. Still very doable, but definitely not the 3-pound weights that we were lifting before. So considering our earlier discussion, I would expect this subscribe on function to change the scheduler for the upstream functions. Let's try it out. The first breakpoint that I hit, you can see I'm on the IO scheduler. And then I'm on the IO scheduler. And the IO scheduler again. And once more, I'm still on the IO thread scheduler. So as you can see, this isn't just affecting upstream, but up and down. Now, why is that? Well, I already explained earlier how subscriptions work, so it makes sense why the upstream is being sent to the IO scheduler. But this also behaves like ObserveOn, in that it doesn't change the thread pool until you tell it to do it again. So that's why it seems like it's affecting downstream. It's because I just didn't tell it to do anything different. In this example, it doesn't really matter where I place the subscribe on function, because it affects the whole way up and the whole way down. But what if I want to change the downstream scheduler? Then I have to pair the subscribe on function with the observe on function. It's dusty. So if I modify the previous example just a little bit, here's what I would expect to see. The first 2 breakpoints would be on the IO scheduler, thanks to the subscribe on. And then everything downstream from that should be on the computation scheduler. Let's see if my expectations are correct. First, I'm on the IO scheduler again, computation, computation. So, we were correct. Didn't I say earlier that it doesn't matter where in our call chain we place the subscribe on function?
In this example, it doesn't really matter where I place the subscribe on function.
Yes, I did. So, let's go ahead and test that out. I'm going to move the observe on function just below my first flat map. So that means I'd expect my first flat map to happen on the IO scheduler, and then computation the rest of the way down. And as you can see, that's exactly what happened. But why? Earlier I said the subscribe on function goes both up and down. Well, yes, that's true, but with an asterisk. In the earlier example, I never told it to change to a different scheduler anywhere downstream. That's why it appeared as though it affected everything downstream. In this example, subscribing, or going up, worked as expected. Subscribe on is really intended for upstream scheduler changes. So it went the whole way up on the IO scheduler. And as things processed on the way down, then it switched to computation. Now you can see why the subscribe on function placement doesn't strictly matter. In my opinion, the second example is bad practice, because we had the observe on and subscribe on functions kind of scattered throughout. I typically like to keep the subscribe on and the observe on functions back to back, because that makes the transition point really clear. This next section here is a bonus, but also here to try and clear up a bit of confusion. What happens if you have an RxJava call chain with multiple subscribe on calls? Well, the short answer is it's practically useless, and I've never done it in production. Let's take a look at an example. As you can see here, I have 2 subscribe on functions. The first one on the computation scheduler, and the next one on the IO scheduler. Let's see what happens. As I step through all of these functions, you can see I'm always staying on the computation scheduler. So why doesn't it switch? Well, it does switch, it's just that you never see it in your operator functions. I'll leave the explanation for this up to David Karnock. He's the lead RxJava maintainer, and he'll explain it perfectly. The short of his article is you don't need multiple subscribe on calls, really, ever. In my projects, I've poured so much time into making sure that my threads were working properly that I completely overlooked another problem. I was polluting my streams. And since RxJava doesn't have any kind of environmental protection agency, I had to wade into these streams and clean them up myself. So, if you want to know how clean or dirty your streams are and how to keep them clean, continue on to this video here. I hope to see you next time on ThoughtFuel. Thanks, and happy coding.